lesson, what is this, 7.5?
Yeah.
Part 2? Okay. We left off somewhere in the midst of example 3 yesterday, correct? Where they gave us an equation. They told us there's 1,200,000 trees. They plan to harvest 7% of the trees each year. X is in years, and they're asking us how many years. So if X is in years and they're asking us how many years, we're finding X. Notice X is in the exponent. So this goes right along with the process of what we were using yesterday. How many years will it take to harvest half of the trees? So one of the things we talked about yesterday is, what does half of the trees mean? And we came up with half of the trees being 600,000, right? Okay, so we had taken our equation, T of X equals 1,200,000 times 0.93 to the X. In place of T of X, we had put 600,000. Now, one of the new steps I talked about here is, before we could take the log of both sides, you can't take the log of this until you have just something raised to a power. So how do I get 0.93 to the X by itself is what I had asked you. So how are we going to get 0.93 to the X by itself? And if we have 1,200,000 times 0.93 to the X, we had to divide it. So we're dividing both sides by 1,200,000. What is 600,000 divided by 1,200,000? And that's a half, right? Half 0.5. Over here, the 1,200,000s cancel, and we have 0.93 to the X. Officially, yesterday I taught you check the gold paper first. Can you get those bases the same using the gold paper?
No.
And the answer is no. So plan B is we take the log of both sides. So when we take the log of both sides, remember that's just writing the word log in front. So the log of 0.5 equals the log of 0.93 to the X. What property can we use next? The power property, and we might have even done this yesterday, allows us to take that X and put it in front of the log. So then I have the log of 0.5 equals X times the log of 0.93. How do I solve for X?
Divide the log.
Yeah. If it's X times the log, we want to divide the log. So we're going to divide by log of 0.93. If I divide one side, we divide the other side, right? Log of 0.93s cancel, and X is going to be whatever log of 0.5 divided by log of 0.93 is equivalent to. This is where I asked you to have a calculator, right? This is a pretty basic calculation compared to some we did yesterday. You guys need me to do this one on the calculator, or are you getting it?
Do you have the parentheses on the
Roughly
bottom?
9.55.
You would not have to have the parentheses on the denominator in this one.
Okay.
And the difference being, yesterday when I forced you, I said you have to have the parentheses around the denominator. It wasn't just a log in the denominator, it was like 2 log something. Okay, that was the difference. And in fact, it was problems like this, where there was 2 pieces, a 3 log 15, a 2 log 5. That's when we had to have the parentheses around the denominator. This one, you don't have to. Now, you will have to when you do the log of 0.5, you will have to end that parenthesis. But then you don't have to put parentheses around the denominator. So, log of 0.93. Okay? I have approximately 9.55, which is what you guys said. And that, of course, is years. If you said approximately 10, I would get that too. Something in Math Excel, of course, they would tell you how to round. I wasn't going to necessarily work the next one out, but I was going to at least address how you would set it up. After how many years will you have harvested half the trees? So still half the trees, but if it says if you harvest 5% instead of 7%, what does that change? If we're still harvesting half the trees, but 5% instead of 7%. 0.95? Why 0.95?
Because you're taking 5% away from 100%.
Yeah, 5% from 100%. So the idea of you'd be doing 1 minus 0.05, which would be put us at 0.95. So instead of using 0.93 from this, you would use 0.95. The rest of the problem would be the same, yes? And in fact, you could shortcut it and jump right to the answer right there. You wouldn't even have to work the whole problem, really. If you work it, I will tell you I have 13.51 written down for my answer. I want to review a little bit. Remember the exponent equations we did yesterday. Make sure you remember, if we can't get the bases the same using the gold paper, we take the log of both sides, and then we're moving the powers out front and dividing, yes? Now, don't forget, let me back up real quick. We also talked about the top half, yes? What was different about the top half? Here, when it was 16 and 8, 27 and 81, we could get the gold paper, or could use the gold paper, right? We could get the bases the same. So always check, can you get the bases the same? If you can't, then we're using logs. Okay? Now, those were all exponential equations. X was in the exponent. What about this last batch of equations? What do you notice about these? Okay, there's no x in the exponent. We have a log already in the equation, right? Or maybe multiple logs. So, we can't really solve a log equation in this form. So, how do we take a log equation and change it to an exponent equation? There's a phrase I've used.
Distributing.
Heard like 3 totally different things there. We can't distribute.
Oh, left, right, middle. Center. Oh, is left, right, center a game?
Never heard of that.
It is. My family likes that game. Okay, but we're going to talk left, right, middle. If Gabe prefers to think left, right, center, it has the same meaning. I'm just going to stick with left, right, middle because that's the common one over the years. I walk into my pre-calc or calc classes and say left, right, middle. They're going to know exactly what I'm talking about. So, my suggestion with log equations, guys, we want to get logs out of there. So we're going to change these to exponential functions. Now, before we do this, what base is this log equation?
Log.
If there's no base written there, we assume it is a base 10. So if your log is on the left, left, right, middle. So your left number is the base. The left number raised to the number on the right. So what is my log equal? And that is 2 is equal to the middle, the inside of the log, which in this case is 4x minus 3. Left, right, middle. We learned that back in, I don't know, 7.3 maybe? I don't know. 7.3 might have been the lesson you weren't here for. So if you haven't gotten caught up on that, that might be.
Is the 10 for the
I can't take the
4x
second,
and
I don't think
-3?
The 10 is the
I mean,
base.
not the 10, the 2. The 2. 10 squared. Log into.
Okay, ask your question again. I'm confused.
Take the 2. Where does the 2 come from in the equation?
It's the equal.
It's this 2 right here.
Okay.
So it's left, the 10 on the left, right, raised to the number on the right,
Okay, raise the number.
equals the number in the middle, or in this case, the expression in the middle, 4x minus 3. Now, the good news at this point, we have an equation that I think all of you can solve if you put your mind to it. Okay? As I said, if you put your mind to it. So if you want to argue you can't solve it, then you're just not putting your mind to it. What do we know about 10 squared, first of all? It's 100. So if that was bugging you, got that gone now. 100 equals 4x minus 3. How do I solve for 4x? How do I solve for x? Get it by itself. So if it's 4x minus 3, the first thing I want to do is
3.
Add 3. If I add 3 on the right, add 3 on the left. What is 100 plus 3? 103 equals 4x. How do I solve for x? Divide by 4. And 103 divided by 4? 25.75. The solving itself is not that hard, is it? It's getting to it. Okay. Let's go ahead and try B, if you will. Log of 3 minus 2x equals negative 1. What base is that log? 10. Remember, if it doesn't say, it's going to be 10. How do I get out of log form? Left, right, middle. So my left is my base. So the base of 10 raised to the negative 1 on the right is equal to whatever's in the middle, which is inside your log, 3 minus 2x. What is 10 to the negative first?
1/10.
If you make it a fraction, it's 1 over 10, isn't it? You could also think that as a decimal if you wanted to. 1/10 is also 0.1 1/10. I don't care what you do. I just know how you guys are, that as we go into these next steps, you'd much prefer being able to put it in a calculator, wouldn't you?
Yes.
So decimals make that easier. Okay, if it's 3 minus 2x, how do I get x by itself? If it's a positive 3,
Yeah.
we're going to subtract 3 to get it to cancel. 1/10 minus 3.
2.9.
How about negative 2.9? Positive 1/10 minus 3. And then equals negative 2x. If I want to get x by itself, we're going to divide by negative 2. Negative 2.9 divided by negative 2. 1.45. Okay. I'm going to skip solving C out if you don't mind. I can tell you the answer. But I'm looking at the fact that C, is it a lot like the last two we've just done? It is. So if you've already worked C, you can check and see that you got my answer. If you haven't already worked C, you're welcome to take a moment and work C if you want. think on the bottom row, I think we're going to do all three, but I think I'm going to go out of order. Just to mess you up, right? Not really my reasoning, but that's what it seems like. So I think on the bottom row, we're going to start on the middle example. And in general, what's different about this bottom row? Yeah, there's more than one log, yes? Can I use left, right, middle currently? No, left, right, middle works when I have one log equal to a value. I no longer have one log equal to a value. However, lesson 7.4, we had some properties that allowed us to combine logs. So if I'm looking at E here, log of 6 minus log of 3x. Two logs being subtracted can be rewritten as one log where the insides are divided. This is what you guys were practicing last Thursday and Friday. So log of 6 minus log of 3x can be rewritten as log of 6 divided by 3x.
Is it a positive? Just positive?
Yes. The subtraction just indicates it becomes division. Okay, so we have log of 6 over 3x equals negative 2. Now we have a log equal to a value, right? So how do I get it out of log form? Can we talk left, right, middle now?
Yeah.
What's my left?
10.
The invisible 10. Raised to the power of negative 2 equals 6 over 3x. Yes, it's a fraction, but you'll survive. We'll get through it. Now, 10 to the negative second. Okay? You can say 1 over 10 squared, which is 1 over 100. If you prefer, you could give me a decimal answer.
0.01.
1/100th as a decimal is 0.01. In other words, if you enter in your calculator 10 to the negative second, most of your calculators are going to say 0.01. Okay. I see a fraction. My fraction is 6 divided by 3x. Yes, the x is in the denominator, a little bit weird, but it's all right. If this is 6 divided by 3x, how do we undo division? You multiply. So if this fraction is dividing by 3x, we're going to multiply by 3x. If I multiply the right by 3x, I'm going to multiply the left by 3x. 3x times 0.01. What is 3 times 100? 300. Or in other words, 0.03. X. In other words, you can multiply, right? Just tack the x along. So 0.03x equals 6 because your 3x's will cancel. Almost there. Final step. Yeah. If it's 0.3 times x, we're going to divide by 0.3, or 0.03, excuse me. And 6 divided by 0.03? 200. It's not too bad for the most part. It's just, I mean, you're going to get a different, and this is why, assuming time, I'm going to do D. I still want to do D and F, because I want to make sure we get a variety of seeing some different equations, but the hardest part is just remembering how to get started. If you can get it started and get head in the right direction, the equation solving is not bad. So, let's go ahead and do F, and then we'll go back to D. Okay? So F. 2 logs are being subtracted. 2 logs being subtracted can be rewritten as 1 log where the insides are divided. So notice I only write log once, but then on the inside I'm doing 2x squared divided by 5.
First one always on top.
Yes. When you have 2 logs being subtracted, the first one will always go on top. Guaranteed. What do I do? It's log base 10. So I'm going to do left, which is 10, to the right, which is 1, is equal to the middle, which is 2x squared over 5. What? No. I wrote the 1 just so there's not a question of where it came from or whatever, but once you see it's 10 to the first, it's 10. You don't have to write the 1.
So on the test, if we get here, do we have to finish it off if we know the answer?
I would expect to see a couple little steps, or no? I'm trying to think. I guess I would expect to see a little bit, just showing me how you get there. But are you saying you can just look at it and you're just looking at it and you're seeing what the answer is?
Yeah.
I get that, but I'd say finish it off a little bit. What are the steps we do here, guys?
Times by 5.
Okay. You see division again? Yes? If this is 2x squared divided by 5, the opposite of dividing by 5 is to multiply by 5. There's a different step you could do too, but I would say most of us would prefer to multiply by 5. If I multiply one side by 5, multiply the other side by 5. Tough math here. Stop and think. 5 times 10? Knew someone had to do that, Kogan. Okay, 5 times 10 is 50. 2x squared is going to stay. The 5s will cancel. Now what? Okay, if it's 2 times x squared, we're going to divide by 2. What is 50 divided by 2? 25 equals x squared. I just brought it over here to have a little more room and to flip it around. Okay, guys, almost there. X squared equals 25. Square root it. When you say squared at this point, I know you guys know what you mean in your heads, so I know you're going to do the right thing. Since it's x squared, we're going to square root it. The square root of x squared is x. Square root of 25.
5.
And you need to consider the positive and negative solutions. Just like normal, when we take the square root in a equation setting, we need to consider the positive and negative. Now, I will say, when you get negative answers today, you need to stop and pause. Is this possible? Because remember, the inside of a log cannot be negative.
No.
But when I take negative 5 here, what am I going to do with that negative 5 when I plug it in?
Right.
I'm going to square it, and that's going to turn it positive. So could my negative 5 work?
Yeah.
Yes, because I'm going to square it. Okay, so this time 5 and negative 5 are okay. I can't always guarantee that, though. Okay, one last one. Then maybe a little bit of work time. D. 2 logs again. What's different? 2 logs being added. 2 logs being added be rewritten as 1 log where the insides are multiplied. So I'm going to write this, and I'm going to go ahead. It's x minus 3 times x Can I go ahead and put the x first, or is that going to mess you guys up? Is it going to mess you up? It always looks weird no matter how I do it. It's x minus 3 times x, or x times x minus 3. Either way. If you prefer the x out front, then do that. Now, what is x times x minus 3? Okay, yes, so we are distributing. So I'm going to go ahead and distribute that and say that this is log of x squared minus 3x equals 1. So 2 logs being added were rewritten with the one log where the insides are multiplied. I now have 1 log equal to a number. So what am I doing? Left, right, middle. My left is 10. 10 to the first equals x squared minus 3x. Okay, so I basically have the equation x squared minus 3x equals 10. I see an x squared term. I see an x term. I see a number term. What's my solving process? We're going to want to get into 2 parentheses. Before we can get into 2 parentheses, we need to make our equation equal to 0. This is old hat, guys. You just have to dig in the depths of your brains here. So, you guys know me. I like to keep my x squared positive. So, how do I move the 10 over to join it? I'm going to subtract the 10 over. So then, I'm going to have x squared minus 3x minus 10 equals 0. I just flipped those 2 sides without even thinking about it. Sorry. I tried to avoid that when I'm up here, but I subtracted the 10 over. It's x squared minus 3x minus 10 equals 0. Our process is to factor. Two parentheses. X squared breaks into x times x. I need 2 numbers that multiply to be negative 10 and add to be negative 3.
Negative 5 and 2.
Do we like Levi's answers?
Yes.
The 5 and 2 are obvious, I hope, because 5 times 2 is 10, 5 minus 2 is 3. If it multiplies to be a negative, I know one of them is negative. If it adds to be negative 3, the bigger number is negative. Am I done? Are these my answers?
No, you gotta finish it up.
And we finish it up by setting each part equal to 0. So x minus 5 equals 0. X plus 2 equals 0. What answers do I have?
5.
Okay, if we add 5, we get 5. If we subtract 2, we're at negative 2. All I'm going to do is exit out. So, okay, I got a negative answer. What did I say over here when I got a negative answer? You need to stop and consider it, yes? Okay, the negative worked okay here because when I put that negative in, I was going to square it. What's going to happen when I go to put my negative in here? Negative 2 minus 3 is going to be a negative. Or if I put negative 2 in here, it's going to be log of negative 2. Any value that's going to turn the inside of the log negative does not work. 5 minus 3 works, and 5 works. You're not going to, I don't know if you'll run into any on Math Excel. You're not going to run into many that don't work. but it is a possibility, so beware. Okay. Your homework, of course, is Math Excel, lesson 7.5. If you haven't looked, it was available last night, so it is possible you started. It is due tomorrow. And you've got about 10 minutes.
Oh, listen to music.